now. This is from question 4. Also from the consolidation quiz. So let me put one sentence at a line so that it's easier to see. The sentences in this question seems to be long. Okay, and I comment them first. Okay, so let's see what this question asks us to do. It says a pentagonal number is defined by Pn equals to this equation, where n is an integer starting from 1. So the example given here is, therefore, the first 12 pentagonal numbers are 1, 5, 12, 22 until 210. A triangular number is defined by the other equation, Tn, where n is an integer starting from 1. The first 12 triangular numbers are 1 until 55. Okay, so it says this part is example, so it doesn't tell us what exactly we need to do in the program. We do know that we probably have to calculate all the pentagonal numbers as well as the triangular numbers, but let's see what the program asks us to do. From the above example, the number 1 is considered special because it is both a pentagonal and a triangular number. Okay, so how many special numbers exist in the first 500 pentagonal and triangular numbers? Okay, so that means when I have this list of number and this list of number, I want to check what are the numbers that appear in both lists. Okay, how many numbers appear in both pentagonal and triangular numbers? Okay, so that's exactly what I have understood from this sentence just now. So we can, based on this concept, to develop the code. So we have seen from here, we need to compare to a list of number in two lists. So that means I definitely need this as the first step, and the triangular numbers as the second step. Okay, and the question says we want to identify the special number exists in the first 500 pentagonal and triangular number. So we know that we need to have 500 numbers in our list. Okay, so if 500 numbers, that means from programming sense, like what is given here, it is supposed to go from 1 until 500. So we can document it this way to keep it as a reminder for us. Then the next thing is how many special number exists in the first 500. So how many numbers appears in both. Okay, to keep this comment simple, I can say how many numbers appear in both lists. Okay, so this could be the 3 simple steps, but let's look into them one by one. First 2 doesn't seem to be too hard to complete. The third one, we might need to expand a bit more with manual analysis, but let's start with one step at a time. Okay, so that we solve one problem or one issue at a time so that we won't confuse ourselves too much. Okay, first I need to calculate the list of pentagonal numbers, and the equation is given here for the pentagonal numbers. So the question says n is going from 1 to 500 because we want to calculate the first 500 numbers. So I know that I definitely need this line where n is equals to 1 to 500. So the next question is just that, instead of using a loop to calculate n, can I actually use this single line equation to calculate everything? And there are a few things I will need to update in this equation in order to type it correctly. Okay, the pentagonal number is 3n squared minus n over 2, and the triangular number is n squared plus n. Okay, so this is 3n squared. Maybe I just update this just in case I forgot later. Okay, so let's try and see if we can generate 500 pentagonal number in one line. Okay, so if I want to achieve that, that means the variable p, I don't need the indexing. Okay, so this equation here just tells me p is a function of n. Okay, it's not telling me about the matrix addressing. Okay, so 3 multiply, we need to inform the computer this is a multiply operation, and n power 2, because n is a row vector, so I need dot power 2. So this minus symbol is a red color symbol, so I need to type minus again so that it goes to the proper symbol that MATLAB can recognize. So this row vector minus this row vector, fine, is not a problem. Divide by 2 is also not a problem because 2 is a scalar, so that can happen. Let's try and see if we will get the 500 pentagonal numbers. Okay, so this is the consolidation quiz, question 4. Okay, so we do get 500 number of p's. If you want to check the number, you can double click on the variable p to view the variable values in the variable window. So we do have this list of numbers over here, so fine, that is fine. And we know that we can use the same approach to calculate the value of t, just that the equation now is this. Okay, so I will have n dot power 2 plus n, so this part is fine. So let me test now, did I get 500 t values also? Okay, so this part is straightforward. The next thing is just how many of them we need to compare. Now, we cannot compare p and t directly because obviously the number is not always the same, right? So if we want, so we need to identify a way on how do we check on this. So if you have no idea, you can do the manual analysis now. It has given us here the first 12 pentagonal numbers, so might as well we just do a quick check and see the value that we got roughly looks correct or not. 1, 5, 12, 22, 35, 51, 70, 35, 51, 70. So the P number looks fine. How about the T number? 1, 3, 6, 10, 15, 21, 28, 36, 45. So everything looks okay. So we have do a quick checking. The P number and T number should be calculated correctly over here. We can now remove these 4 lines. We are done with it. Okay. Now we need to go ahead to do this comparison. So you cannot do a comparison like just simply compare P and T because the position of these values are not really the same. Okay, so I think there could be several methods on how you will do this. So let me just use the first idea that comes into my mind. We will do a manual analysis and see it helps us to see the pattern or not. If I want to compare 2 sets of numbers, but they have missing numbers inside them. Okay, so that because we can see in P, I don't have value 2, 3, 4. And in T, I have value 3, but I don't have value 5. So in this case, because of this situation, I cannot do P equals to T comparison directly. So the comparison, I have to base on one list and compare with the entire of the other list. So what I mean is something like this. So in my analysis, let's say if I say, I will put in my comment that how many numbers appear in both lists. So let's say my step is I'm going to compare based on one of the lists. So I will just choose P since it happens to be the first one that I created. So I will compare based on P list. So that what it means is that I will actually take the value from P one at a time. Okay, so when I take the value from P one at a time, we can see from the, remember the first P value is 1, so it's 1. Okay, what I'm going to do is I'm going to do a comparison now with this P, which is equals to 1, and let's say I will put it like this, Pi is just one of the value of P. I want to compare with the entire T list so that I know this first number is inside T or not. This is the condition that I'm comparing. So perhaps it's more appropriate to document like this. So this is the comparison. Okay. So I just want to document that I'm going to have to perform this comparison. And what I have here in the next column, I could put the T list. Okay, so T list has 500 numbers. Of course, in the manual analysis, we don't need to look at all 500 numbers. We can just take out a few as an example to help us to understand the pattern. So let's say I just take up to 15, okay? So I know that my T list is equals to 1, 3, 6, 10, 15. Let's say I use a smaller set of numbers to help me to understand the situation. So now, if the value of P is 1 and I'm comparing with this whole thing, after I perform this comparison, what do I get? Okay, that means I'm comparing 1 with all this. So perhaps it would be easier for me to show things like this. I will document this is the T list of the number. So if I do this comparison when P is 1, then what I will get is this is true because it's the same number. This is 0. Okay, so take note that I'm going to get a result as a vector when I do this comparison because P is a scalar and T is a vector. So this is 0, this is 0, this is 0, of course. And what is the second value in the P list? We can check on that so that we understand what happens in the pattern. If I take the second value, which is 5, so what will happen? 5. Of course, I will do the same comparison. Now, if it is 5, then I will get 0, 0, 0, 0. Okay, let's try 1 or 2 more values. 12. If P is 12, at least in this first set of numbers, is still 0, 0, 0, 0. Okay, so let's just, for testing purpose only, we investigate and see what if the next value that appears is 15. Okay, this is not extracted from P list, but I just want to observe the pattern. Then I will have, when the next number that matches in the list, I will have another 1 over here. Okay, you can indicate this is for testing purpose only, so that it reminds ourselves the value 15 is not the actual number that is inside the P list. We just want to see how this comparison will work. So we can see that if we do so, we can get the attendance of the numbers every time we compare. If this number appears in T list, then we will have a 1 somewhere. If this number doesn't exist, we will not have any 1. Okay, so that's the pattern that we have. That is the pattern that we observe. So maybe what we need to do is we want to identify how many numbers appears in both lists. That means I want to count in all these iterations, how many ones do we have. So an easier way to achieve that is perhaps outside of the table, I will sum this comparison result so that I get 1, 0, 0, 0, and 1. Okay, then I can sum this. Then I'm able to compile all the results from the entire list of the P. So which means after I compare all the P values with T, I just sum it up. Then I will get all the ones in a single row vector. So that way I don't need to store a two-dimensional matrix from this iteration. And once I sum already, I get this. Okay, so I would call this is going to be similar to the adding the series terms. Okay, so if this is what I want to achieve, after I accumulate the sum, then I will be able to just sum this entire vector. Okay, let's say sum the above vector, which will give me a total count of how many values appears in both lists. Okay, so looks like that will do the job. So let's try to make this code happen. Okay, now I'm going to take the value of P from the list one at a time. So this is a fixed list of 500 numbers. So I know I can use for loop in this case. I don't need a while loop because we are not looking at any form of condition. So since I want to take one number of P at a time, so I can just say for P. Okay, P is already 500 numbers. So this can be the control variable. It already contains value, so I can just put for P. Okay, so if you're not sure if this line would work, you can just use DISP to print the value of P. Then you realize that it won't work. I need a control variable I equals to P. Then let's see if it is able to, I will be the value of P1 at a time in the iteration. So I just run this and I can see that, okay, 1, 5, 12. So it will be inside the for loop, I'm getting one value of P at a time when I have this code. So I is the one that I can use to compare with the entire list of T. So I already have I equals to a number here. I can just do a quick try in the command window. What if I is equals to T? So we can see that the ANS variable, it contains 500 logical, and we can see from here is a 500 of 1 and 0. So one of it will be 1. We don't really need to bother where is it. We know that this comparison will work. So after I'm able to use the loop, the for loop, to extract one value of P here, then the next thing is the comparison. So I will just say I is equals to T. Okay, now should this be a condition or what? So that's what we need to look at. Once I do this comparison, I get a vector of 500 values. And what I want to do is accumulate the sum based on what we have seen here. So in that case, it doesn't really involve situations where if true what we do, if false what we do. Okay, we just want to add everything together. So if I just call this check, okay, so that I store this whole list of 1 and 0s into the variable check. And we try and see, okay, we get check as 500 logicals. And after that, sum the above vector. So if I do it like summing the number of terms in a series that we sum one term at a time. So similar to increment the value by 1 that we have count equal to count plus 1. So now we can have check equals to check plus. Okay, so I cannot plus 1 or what, but I can still use this format. Check is supposed to be, I supposed to add check into the accumulation sum. So let's say I just create a variable that I call it collect all, or just keep it shorter. Let's say sum all. Sum all equals to sum all plus check. So that will help me to add up all these things and give me a vector like this. Okay, now if I have this line, let's check for the initialization. In this code, if you want to make it easier for you to understand, you can just put a round bracket, even though with or without it doesn't matter. I need the value of I, which is a control variable, so no need initialization, is fine. I need the value of t, which is already here, so that is fine. Check is going to be calculated before this line, so it will have some numbers to calculate, so it's fine. Sum all does not exist yet when we are running the first iteration of the for loop, so we need the initialization. So sum all is equals to what? Okay, so before the loop starts, sum all should have nothing, right? Because we haven't do any comparison yet. So in that case, we can see that these are all 1 and zeros. So before the loop starts, the total sum should start with everything is 0. So that tells me I can initialize it with 0, and it should be the same length as the T list. Okay, so therefore I need to have one row, and the number of column is same as the length of T. Okay, so I can just test this and see if I got 500 zeros in sum all. I have 500 values, so that could be fine. Now let me run this and see if it generates any error first, so that I could fix it before I write even more codes. Okay, no error, and sum all do have 500 values. Now I need to know inside sum all shouldn't have only a 1, it should have many ones. So let's just do a quick check. If I just plot sum all, because 500 numbers, is going to be hard for me to look at it from variable window. So let's use plot to view all 500 numbers. Okay, it is done. So the figure should be okay. So we can see that mostly is 0, but we do have some spike. So these are the ones. So that means there is more than one number which appears in both lists. So this approach seems to be fine. We just need to use the calculation to get us exactly how many of these. So as we have done here, we need to sum the above vector. So the count that I need is just going to be sum of sum all. Okay, so let's check and see, do we get a single value from this count? Okay, so count is 3, is more or less same as what we see from the plot just now. We do have 3 numbers that exist in both the P list as well as the T list. How about 1000 pentagonal and triangular numbers? So we can try and see, does the count increase to more than 3? But right, it should be at least 4, right? No, we still have 3. Just to make sure that it really doesn't change anything, let me put clear and CLC. So maybe we need a much larger number to see some difference. Yeah, count is still 3. So 500 and 1000 doesn't make any difference. So if I put 10,000, okay, now we have 4 numbers that appears in both lists. Okay, 100,000 Okay, maybe 100,000 takes a little bit longer. Now 100,000 only, we got 5 numbers that appears in both lists. Okay, but at least with this quick testing, it looks like this code works correctly. So we have completed this.